Hey guys, thanks for popping in. Yeah, just probably a bit of a chat that I'd like to have a bit of a discussion about bike tech. And we have a lot of shows on the internet, some even are sponsored, which talk about tech, and some are actually even called tech shows. And they talk about, all that sort of stuff that's related to bikes, technical design, why they're designing wheels this way, the latest tech that's coming out, new innovations. We have all this sort of stuff, and it's very interesting. And I work in a technical field, and I actually like watching a lot of this tech stuff. But I must admit, in recent times, I've become a bit jaded about what tech they're actually bringing to the market and how effective, or does it actually even really work. And I like to follow a lot of other people that are subject matter experts in the field of carbon and also bearing designs, aerodynamics. And when you actually watch these people, they give explanations that really don't align with the tech that a lot of these bike manufacturers or these shows that are basically endorsed by these bike manufacturers, it just doesn't add up. So what sort of things are we talking about? Well, basically, we're talking about innovations, and one that comes to mind is the one manufacturer actually has these type of dimples on their wheels. And we see these dimples on these wheels, and, we associate with that dimples on a golf ball, and most people know that, if they're tech-minded, that a golf ball has these dimples on because it actually goes faster through the air. It creates less drag. So you go, hang on, so we can put these dimples on bike equipment and they will also go faster through the air. It makes sense, right? That's logical, okay? But what actually happens is, in reality, is that there's only a small window of speed where this technology works. So what it's got to do with, it's got to do with the wind going over the golf ball, and at certain speeds the dimples make the wind stay attached to the golf ball, so therefore you get less turbulence, so the ball travels faster, okay? And if you put this on a bicycle wheel, if the wind stays attached to the wheel, then you're going to get less drag, and of course then your watts are going to have more of an effect of pushing the bike forward. But in reality, the speed difference of a golf ball to the speed difference of a bicycle wheel is huge. And the reality is, at slower speeds that we're traveling on a bicycle, this effect of the attachment of the wind just doesn't apply. So, I don't know, do the manufacturers who are making these wheels actually know this? Or are they just as dumb as all the rest of us and swallowed the Kool-Aid? Because the reality is they don't work. They're just a nice decoration on these wheels. And then we have bearings, and these have been promoted, especially in more recent times, with some of even the new group sets they're incorporated. And we're talking about ceramic bearings compared to steel bearings. Now, ceramic bearings, yes, they say that they can make the balls more round, so they're going to roll better, whilst steel bearing is much harder to make real round. And this is what they tell us. And then you see these things where they spin the little gears, and they go, and they seem to spin forever. And you go, oh, well, that's great, So if I'm pedaling and I have these bearings on my bike, I'm going to go faster. We look at these bearings. Now, the first thing is that we go into that on a derailleur, the jockey wheels have no load at all. There's no load for you pedaling. Only the top part of the chain actually is loaded. The bottom part of the chain is just returning. It's going through the jockey wheels, and the only tension that is applied to that chain is a spring that's in a derailleur, and that spring basically keeps it taut. Otherwise, you wouldn't be able to change gears. The derailleur needs to take up that slack. Are we getting any benefit having a more free spinning bearing on the non-load side of the derailleur? That's a question mark. Now, I don't know the answer to that, but I would probably say that if it does make a difference, you would probably be in the realms of milliwatts, not watts. So that's the first thing. And then we actually look at the bearing itself. Now, okay, ceramic bearings, you go, oh yeah, they're more round and that should roll better and that causes less drag. And yep, I'm going to ride my push bike. Hang on, there's a little bug here. Sorry, trying to get me. And you go, yeah, I'm going to go faster, man, you know, and the pros use them. And a lot of these manufacturers have adopted these ceramic bearings, and they've even actually adopted a specific manufacturer that specialises in these type of bearings. But the reality is that, again, it's not applied in the same application that ceramic bearings were designed for. Ceramic bearings were designed for high-speed applications, and that's where they really shine. A bicycle's not doing those sorts of revolutions. I mean, when we're pedaling, we're doing maybe 105 RPM. I don't know. If you're really good at cadence, maybe 120. Some of the people that do track work, maybe a little bit 130. I don't know. But it's not 20,000, it's not 30,000. And how fast are the wheels spinning? The wheels rotate quite slowly as well. Your jockey wheels are probably spinning the fastest, which are non-loaded. So are we really getting any benefit? And if you actually look at manufacturer specifications, then these bearings, steel bearings, some of them outperform these ceramic bearings. And that's actually from the figures given by the manufacturers at RPM. And then we have disc brakes. Now, you know, people are saying, you know, they stop you quicker, you know, disc brakes are better. Well, I will actually say I haven't heard any data from manufacturers that specifically state that disc brakes brake better. Okay, so I'm not going to rag them in this case because they're not making those claims. But they are fitting them to bikes and they are trying to promote them as a better technology. Now, that's fine, and, you know, to me, disc brakes do have advantages, especially on things like gravel bikes or mountain bikes where you have a problem with contamination on the rims. A disc brake is going to be superior. It's the same also in wet weather. Some rim brake pad disc combinations work really poorly in the wet conditions, and disc brakes are a much more consistent braking system in wet conditions. So you're not reliant so much on the brake surface or the type of pad that you have on rim brakes. Now, you know, I have some aluminium rim brakes with aluminium pads and they work really well. I have some Campagnolo carbon brakes on carbon rims and they work terrible in the wet. Then I have some Reynolds carbon pads with carbon rims and they work about in the middle, so in the wet. We're just talking about wet conditions here. But in the dry, it's a different story. The Campagnolo brakes on the Campagnolo carbon rims really are incredibly quick at stopping. The braking power modulation is outstanding. The Reynolds are not quite as good, and the aluminium brakes are probably the worst in modulation and absolute braking power. But they are all relatively good, which means I can brake hard enough to lift the back wheel on the bike. So let's just say you've got a top-end road bike, 20 grand. Are you going to be using that as a commute and ride around in the rain? I mean, if you live somewhere it rains all the time, maybe you do want disc brakes. But if you live in a pretty fair weather climate like Australia, $20,000 bike, my best bike, I don't ride in the rain. I've got another bike that I ride in the rain. No one has shown me, I haven't seen any data anywhere, and I look for this tech on the internet. I haven't seen any data that substantiates that disc brakes stop quicker than rim brakes. So where are we with all this tech, and what do I know? But I can get on the internet and I can Google just as good as anyone else, and from what I can tell from people who, what I call subject matter experts, not bike manufacturers, but subject matter experts, and the tech is misappropriated to that type of a piece of equipment, we really have to ask ourselves, what the hell are we paying for?